Okay, so let's try to understand a new definition, an understanding of what an acid is. If we take a standard acid like HCl, maybe the most simple, maybe the most simple acid there is. Now, if we just have hydrogen chloride, as this would be called, this is not actually an acid. It's only an acid once it's dissolved in water, like that. So now we've got state symbol AQ. And what happens when it dissolves in water in reality is although this is a covalent molecule, if you went on to do A-level chemistry, you'll learn that covalent molecules and ionic bonds, it's not a kind of this or that. There's kind of a spectrum between the two. So in a way, this kind of separates in a way that it would be an ionic bond. We say it disassociates. So it splits up into a hydrogen ion and a chloride ion. And these would also have state symbols. Now, a strong acid completely disassociates. Okay, so all of the high HCl becomes H plus and chloride Cl minus. This is a hydrogen ion, as it says, a positive hydrogen ion. If you think about what a hydrogen atom is, it's got a mass number of 1 and an atomic number of 1. So I'll leave those on actually. So we've got 1 proton, and we've got no electrons because no neutrons, because if I had a neutron, the mass number would be 2. And so if we put the shell around it, it has to have an electron to cancel out the positive charge. So now that's a neutral hydrogen atom. And H plus, to make it positive, I need to remove an electron. There's only 1 electron to remove, so I remove that electron. And what do we have? We have just a proton on its own. So maybe I'll just delete that now, so that is the same as that. But we can see that this is just a proton. So this hydrochloric acid disassociates and produces all these protons into the water, into the solution, the acidic solution. We can say that it donates these protons to the solution, and so a definition of an acid is a proton donor. Now, what about a pH scale then? What is a pH scale measuring? Now that we have a new definition of an acid, which is a proton donor, before we thought of a pH scale as being just how acidic or alkali it is. And strangely, the middle amount was a 7, which is really strange to have a middle. The neutral value was 7. You would have thought the neutral value would be 0, then maybe alkali would be negative and acid would be positive, all the way around perhaps. But it's somehow at 7. The reason for that is, and this bit is beyond GCSE, so I won't go into too much detail, but it really means the concentration. We're really talking about the concentration of these protons within the acid. So if there is a high concentration of protons in the solution, then we have a low pH. Now, we only think about pH as being between 1 and 14. But it can actually, I think it can go higher than 14. It can certainly go lower than 1. It can go down to 0. In fact, I think you can even have a minus pH. But it's measuring the amount of ions, amount of protons inside this solution. So if you were to then if you were to add more acid, more molecule here, you have a high concentration of acids, you're going to lower the pH, because that means to have a high concentration of H plus. So what does an alkali do? An alkali shifts it that direction, so it produces a low concentration of H plus. So what would I actually have to do if I had a acidic solution? What would I have to do to reduce the number of H plus? If I'm putting something in, how can I cause something else to reduce? What if an acid donates protons? Guess what an alkali does? It receives protons. Okay, so it takes protons out of the solution and kind of produces something within the solution that absorbs those protons and therefore decreases the concentration of the protons in that solution. How they do that is complicated. We'll look at that in a moment. I'm not sure how much in depth you need to look at it for GCSE, but we'll go through these notes now and see how that works. But again, the main points are that an acid can be defined as a proton donor because they produce these protons, which then go into the solution. An alkali is a proton receiver, or I'm not sure if receiver is the key word there, but it reduces the amount of protons in the solution. And then pH is really just a measure of how concentrated the H plus is, only it's in the opposite way around. So a low number means a high concentration, and a high number means a low concentration. Okay, yeah.